With long division, we solve it basically the traditional way that it's always been taught. So if I'm dividing this by 7, I'm going to follow this process. Divide, then I multiply, then I subtract, and then I bring down. And I like drawing this diagram for the kids because the kids a lot of times get confused when they go from division to putting their multiplication amount down. They forget what it is. And then when they bring down the next number, that restarts the cycle of division, and it lets them know that, hey, they're dividing the bottom number. So if I go through this, my first step is I'm going to divide. I'm going to check, can I take any 7s out of that 3? No, I can't. So now 32. I can take 4 7s out of that 32. Okay, so then I'm just going to multiply now, and I multiply how many 7s did I take out of 32? That number I just wrote down for my division. My division always goes at the top. 4 times 7 is 28. Then I subtract. I get a 4 there. And then after I subtract, I bring down the next value. So really I'm looking at how many 10s I have left in this number. And since I brought down, I need to divide, and I need to divide that bottom number. So how many 7s can go out of 45? This is my division step, 6. And then I multiply the number of 7s I could take out of 45. So 7 times 6 is 42. And then I subtract 3. And then I bring down that 6. And this is telling me how many 1s I have left. So now I'm going back up to division. I'm dividing the number of 1s I have left on the bottom. How many 7s go out of 36? 5. 7 times 5 is 35. Subtract, bring 1, remainder 1. Now, some things that I do that you might not have done is I draw arrows, because the kids a lot of times will accidentally bring down the same number twice if they don't keep their work correctly. So that's how I teach long division. I do show them the expanded algorithm on this so that they can understand, why are we placing the 28 here? Why are we placing the 42 here? The 35? Why are these numbers randomly falling down? Because when we get on that, like later on in math, when you're dividing polynomials in algebra, it's going to be helpful to have a good understanding of this process so you can apply it to the more abstract. So I'll show you an example of this. I won't have the kids actually practice this much in class besides with me walking them through it. So it's basically the same process. I'm just looking at how many 7s can I take out of each group. Well, I can take out 4 out of this hundreds block. So I'm not just taking 4, I'm really taking 400. So before, when I placed the 28 here, the reason is because it was 400, and 7 times 400 is 2,800. So that's why that was lined up there. And then when you subtract, you're basically just bringing down these next numbers. And then we're going to go through and repeat the process. How many 7s can I take out of 456? Well, I can take 6 out of there, so I can take 60. 7 times 60 is 420. And again, that's why I put the 42 at that spot whenever I subtracted before. And then lastly, how many 7s go out of 36? 5. And then I have remainder 1. So if I add this up quick, 465, remainder 1. So that's the expanded algorithm that I'll talk about, but I won't have them actually do. I'll have them practice most of the time with the actual long division process.